Hi, it's time for another math easy solution. Turn to discuss further into differential equations and now look further into separable equations and go over example 2 of the example series and solve this example, which states basically solve the differential equation dy over dx equals to 6x squared all divided by 2y plus cosine y. And as you can see from this is a separable equation, because you can separate this by moving all the y's on one side and all the x's on the other. So to solve this, basically what we're going to do is move this, multiply the bottom here but on both sides so that we can move this y's on the left side and the dx on the right side. So what we end up getting is this 2y, let's write this like that, 2y plus cosine y when we multiply it out, dy, and move the dx onto the other side, 6x squared dx. So we have this, and now what we can do is, like I explained before, on separable equation, we just take the integral on both sides. And now when we do this, we can basically integrate, because everything on the left is in terms of y, and everything on the right is in terms of x. So when we integrate this, the left side is in terms of y, so 2y integral of that is just y squared. Well, it's 2y, then y squared over 2, and then plus cosine y, integral of cosine is just sine y, and we always have to add a constant c. I'll call this c1, because we're going to have a constant on the right side as well. So this one's going to be 6x, the x squared becomes x cubed over 3, and then plus a constant c2. Now we could write this as, simplify this further, y squared plus sine y, and move the c1s on the c1 to the right side, and this will be 2x cubed plus c2 minus c1. These are just arbitrary constants, but again what we could do is let c equals to c2 minus c1, so that this subtraction of these two arbitrary constants is in fact just another constant. We'll call that c. So our solution, well, in this one we can't actually write the explicit solution, so what in fact the furthest we can get to is just writing this as y squared plus sine y is equal to 2x cubed plus a constant c. And yeah, like I just said, basically this equation gives the general solution implicitly. So saying basically y is a function of x right here, this is generally or implicitly how the y and x's are related, but in fact it's actually impossible to solve this particular equation to express y explicitly as a function of x. I don't know why I moved there. So it's hard to do that. Actually, it's impossible for this situation. So in this, we'll just leave it like this in this implicit solution. But in fact, some computer algebra systems can in fact just plot these curves defined by implicit equations. So even if you don't have y as a function of x directly, you could still graph these out using some computer systems. And the graph below actually shows several solutions corresponding to different values of the constant c. And this graph was produced from this website. I'll go to it in a bit. Basically, this is how the graph looks like. For the red one, we have y squared plus sine squared, plus sine y equals 2x cubed plus 3. So that's our c. That's our c value, and this is going to be the red. This is when c is equal to 3. And then I move down here for c is 2. That's the orange. So it looks something like this. C equals to 2, and then the red is the yellow is 1, so this is c equals to 1. Then here the green is c is 0, so that's c equals to 0 now. And then going to the negatives, this is c is negative 1 right here, this is c is negative 2, and then the last one, the purple, is c is negative 3. So yeah, that's how the graph looks like. If you were to graph several of these solutions for different values of c. And now if we go to this website right here, have it like this, so you could basically, I just type those in. So if we go 3, and then you can add an equation, instead of copy this, paste it here, and then change this to 2, etc. Just put a 2, and it just automatically graphs it out. So there you go, it just graphs it out. You could change this. I have this to 2. And then this one, change this to 2. Show you some cool stuff you could do with this calculator. Just graph any type of implicit equation like that. And then 4, so just make it our graph. And there's one more thing I wanted to show on this, found pretty useful. And let's just cancel this one. Let's just put this, if you write it as an m, so instead if you use the variable m, just consider it as our c, now you just press up or down. And it just goes down by 1 every single time, and you can see how the graph changes. Just keep doing this, press it again. Yeah, and it keeps going and going, etc. So yeah, just check out this calculator. It's pretty useful, and it's really nicely presented and really functional. Anyways, that's all for today. Hopefully you'll learn from this pretty interesting example video on this, basically on solving this separable differential equation for the case where you can't actually solve it explicitly, but this is basically as far as we can get like symbolically, but then obviously computers can still approximate or graph out the solutions pretty accurately nowadays. And again, make sure to check out this calculator. It might be useful for whatever you're doing. Anyways, that's all for today. Hopefully you learned, and like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.